Good morning time, good afternoon time, good evening time, whatever the case may be in your part of the world. Crisscrossing wires. And I'm going to discuss a few things with you guys today that you will probably never hear on any other e-bike YouTube channel out there. And just because you may have not heard it does not mean that this is not true. See, most guys that are building batteries or building bikes, I'd say 80-90% of those guys really have no formal electronics training at all. So the stuff that I'm going to be talking about today, they most likely are pretty clueless about. And if you ask them these questions, they would probably say that it doesn't make a difference. And I'm going to say, in the grand scheme of things, it may not make a big difference to the average e-biker. Now, if you're an e-biker like myself that's going into competition and that also wants your e-bike build to be the best, perform its best, get optimum efficiency, then these things are going to be important to you. Now, everyone on my channel knows that I haven't been e-biking for a long time. So while I may not have lots of experience, years and years of experience in the e-bike world, and for that reason I may not know each and every motor brand there is, brands of brakes, wheels, and you know who makes what for e-bikes, blase, etc, as far as component wise, and companies that build e-bikes and all that. I do have over 30 years of an experience in electronic engineering technologies. So I am an electronic technician that is going to apply the knowledge that I know about electronics to e-bikes. That is going to make my e-bike builds pretty much be on an entirely different level than the average bike maker. Okay, and I've said this before, and I'm going to explain to you why this type of stuff makes a difference. Now, what most people don't know, well, let's just say, I'm sure a lot of people have heard of Ohm's law, you know, and that formula, and you know, the formula for power, you know, the basic stuff. But there are formulas for everything, and these formulas can help us make calculations so we get the best performance out of everything. Now, when it comes to power, that's a combination of volts and amps. And in that calculation, in order to get power, you multiply volts times amps. In circuitry, you not only do you have volts and amps, you have other factors such as capacitance, inductance, and resistance. Now, resistance is exactly what it sounds like. everything has an internal resistance. Wires have an internal resistance. Although it's low, they do have an internal resistance. And most importantly, batteries have an internal resistance, which is why I'm just saying what I'm saying now. Now, all batteries have an internal resistance that can be measured with special equipment or calculated with the right formulas. Okay? That being said, each and every battery, I might have just said this, has an internal resistance. Okay? So, high resistance obviously is bad. Low resistance is good. Now, if you were to measure several different batteries, they would all have different internal resistances. And after you put a lot of batteries together in series, parallel configurations, combination circuits, that changes the entire impedance of that battery. Impedance is the same thing as resistance. It's the overall resistance of a combined circuit. That is your impedance. Now, the reasons why not only batteries, motors, controllers, any type of electronic components get hot is because of their resistance. Okay? When you have a high internal resistance, you're going to develop heat, and when you're making heat, you're losing power. Alright? Now, let's just say I'm going to throw around some easy numbers to make it easy. Now, when I say these numbers, I'm just making them up in my head. The actual resistance or impedance may not be, the real calculation. I'm just going to say some basic numbers so you understand. Let's just say this big battery here was 12 volts. Alright? And let's say this 12 volt battery had a 1 ohm resistance. Alright? That means there's a voltage drop across this battery. So instead of you getting the 12 volts that you should get with that voltage drop, it may only measure 10.8. That's because you have that internal resistance. If it's 1 ohm, 10 ohms, whatever. I'm just making up the ohms. Alright? Now, internal resistances of batteries, electronics equipment can be calibrated. Let me use the word calibrated, or changed, or tweaked. Let me use the word tweaked. Now, I mentioned before in another video that the length of power wires, the gauge of power wires, and all of that stuff made a difference when it comes to efficiency. And the reason why it makes a difference is because, like I was saying earlier, that even wires have a resistance. Although it's low, they do have a resistance. And if you're talking about a small gauge wire as opposed to a larger gauge wire, and you're running high current, obviously that smaller gauge wire is going to have a higher resistance, and that bigger gauge wire is going to have a lower resistance. So that means when you run current through that little small wire, because of that high resistance, you're not going to get the optimum current flow, And not only are you not going to get the optimum current flow, you're going to lose a lot of your power, because think of electricity as water. Huge, large amounts of water can't flow through skinny wires. You know, if I was trying to push water through this wire, it would, no way I could pull the same amount of water through this wire as I could through this big thick wire. Now, the difference between water and electricity is when you're trying to pull electricity, large amounts of electricity, current, through small wires, that internal resistance is going to cause a lot of heat. You can actually try to pull too much current flow through a skinny wire, and you will burn the wire up because of its internal resistance and it not being thick enough for that current to flow. Now, we're not going to go as far as the burning up wire parts and all that, because let's just say for the most part everybody has the right gauge power wires on their batteries. Let's hope you should have at least a 8 gauge, 4 gauge, 2 gauge, or 1/0 pretty thick wire on your battery. Now, what makes a difference between even though you may have 0 gauge wire on your battery, the same as I do. Let's say you had a battery exactly like this battery. You know, this is a 60 volt battery. You had a 60 volt battery as well. Now, both of us have 0 gauge wire on our batteries. So you would assume, because you're running the same gauge wire as me, that you're going to get the same performance as me. Now, true, you may get close, and we may get really close to the same performance when it comes to speed or whatever. I may be a little bit faster, or you may be a little bit faster. But what the difference will be is our internal resistance of our batteries will definitely be different. Now, when I calculate my battery's internal resistance, if it's high, there are formulas I can use to calculate the right gauge of wire to use, the length of the wire, and the thickness of the wire. I can use a formula to tell me exactly how long and how thick my wire should be to tweak that internal resistance from, let's say, 1 ohms down to 0.1 ohms. Okay? Yes, you can tweak the battery's internal resistance by knowing these special formulas and cutting your wire length to an exact different length. You know, in transmission wires, it would be wavelength. That's a whole nother thing there. But, you know, length of wires makes a difference. Now, like I said, I say all that to say that this battery that I made, I have measured its internal resistance. And after I measured its initial internal resistance, I can do impedance matching with these power wires to bring its internal resistance down to the lowest ohms possible. Now, the reason why that's good is because if a battery has high internal resistance, as I always told you before, when you're operating with this battery, it's going to produce more heat if it has a higher internal resistance. And it's producing more heat because of, again, that resistance. I've said this a number of times, but I want you to get it. So that means my batteries are most likely going to be a lot more efficient than the guy that knows nothing about what I just said and just built the battery and put a power wire on there, didn't do any, you know, of the fine electronics calculations like I did. He just took a piece of wire off the roll, cut it, stuck it on the battery, put an end on it. Didn't even think about it. Done deal. And will it work? Yeah, it'll work fine. Probably won't have any problems at all. No problem. Matter of fact, you won't have any problems at all. It will work fine. But someone like me, I'm going to take it to the next level. Like I said, I'm going to do impedance matching with my power wires. That way, everything is 100% efficient. When I tell people that I'm running 30,000 watts and nothing is getting hot, they don't understand that or don't believe that. And the reason why my stuff is not getting hot is because of impedance matching. And I'm talking about impedance matching my phase wires, my battery wires, everything. Now, that's as far as I'm going to go into that, but that is the secret differences between an engineer and a technician building something and just a craftsman building something, because he's repeating what he saw being done somewhere. Anybody can watch somebody build a battery, do the basic stuff, and if you're good with your hands, you can repeat that process. But if you don't have any knowledge as far as the theory behind it and the fundamentals, you can't take it to the next level. Sure, battery builders out there can build batteries. They will perform fine. You won't have any problems at all. But, you know, someone like myself, because I want the best of everything, I want to get maximum performance. I want to get every little drip drop, the difference that's going to separate my bike from the next guy's bike, my battery from the next guy's battery, blah, blah, blah. You know, I had somebody tell me that because I wasn't welding my batteries, that I wasn't doing them properly. And I told them I was soldering them. Now they think just because they see most of these battery manufacturers welding, you know, and welding batteries and doing all that kind of stuff. Stand by for a second. Okay, I'm back. So, like I was saying, they think because most of those battery builders are welding using nickel strips, that is the best means to do it. No, that's not the best means to do it. That's the fastest and easiest way to do it. Soldering takes much more time to do, but at the end, it's much more efficient than welding. Spot welding is exactly what it sounds like. Spot welding. Two little electric pulses that, you know, basically just fuse the materials together in two little spots when you weld, you know. And because you have two conductive materials you know, held together tightly, and then you do those little spot welds, it's fused together, so you have the surface area making contact, but the only physical connection you have is that little fused metal from that weld. Now, when I solder my batteries to copper, that is a much better electrical connection, because I'm using molten solder. Solder is tin and lead and it's very conductive. It's basically like when you solder, it's basically like you're melting metal that is conductive, and that, you know, you're bonding two conductors together, especially copper. Copper is a much better conductor of electricity than nickel. Gold and silver are the best, but for obvious reasons we can't afford to use gold and silver connections or boards, you know, or gold strips to put our batteries together. However, you know, people like NASA use it because they need the best of everything, and, you know, they'll use some gold. But anyway, like I said, just because you see these companies using nickel and welding it does not make that the most efficient and best way. Copper is much better than nickel. That's why all electronics have copper boards in them, and all electrical components aren't welded to the board, they're soldered to the board. Solder is the best means of making electrical connections. You know, someone that doesn't know will assume that welding is a better connection. No, it's not. Now, the next thing is, everyone can't solder. Anybody can, well, I ain't gonna say anybody can weld. And I ain't talking about regular welding with the electrodes and, you know, the little sticks and everything. I'm talking about spot welding. Anybody can spot weld, because that really doesn't take any skill. You're just, you know, holding it up there and putting your foot on the pedal or pushing it to the electrodes, and it makes the weld. Everyone can't solder. You know, it takes skill to solder. Not only that, everyone definitely can't solder on batteries because of thermal runaway. It is dangerous for someone that doesn't know what they're doing to solder on batteries, because if you keep the soldering iron on the batteries for too long, then make the batteries too hot, you can sit there soldering batteries and cause those batteries to catch on fire. You have to definitely know what you're doing to solder batteries. However, if you can solder batteries, that is the best way to do it. All right, that being said, that's enough of that. I wanted to discuss something else. I talked about the internal resistance and heat and impedance matching. All right, next thing I want to talk about is the prices of my batteries. Now understand, I didn't start building batteries or start with trying to sell these batteries initially. I made a battery for myself. After people saw how I was making my battery and how my battery performed, then I had people asking to buy my batteries, okay? So it's not like I was soliciting sales. I had people that asked me, could I build them the battery? So that's where we are now. So let me tell you how much I'm charging for my batteries. I'm going to make a flat rate for making my custom batteries, no matter what size they are, no matter what cells you use, whatever. My labor is going to be the same across the board, and that is $1,000. That is the labor I'm charging. That is what it is worth to me, because I know the time and work that I'm going to be putting in on a battery build. A battery build will take me anywhere from 8 to 10 hours if I was doing it non-stop. That equates to about $100 per hour. Although for the most part I won't always be doing them non-stop. I give myself roughly anywhere from in the beginning, starting out, I'm gonna give each battery build at least a week, because anything can happen. You know, I may get some bad cells or something, and I may have to get some more. I mean, just anything can happen. I got life going on. I'm a family man as well, so I can't do this full time all day, but I'll do it when I can, as fast as I can. So let's just say about a week per build, I'm charging, once again, $1,000 per battery. Now, here's the thing. If you think about it, the average battery, let me just use my battery as a hype, you know, as let me use my battery as an example. All right, and I have a big battery. My battery is almost 60 amp hour. All right, now the cells for my battery cost me about $1,200 for 300 cells. Okay, $1,200. So if I was to build that same battery for somebody else, that would be $1,200 plus $1,000. That would be $2,200 for a 21S 15P battery, almost 60 amp hour, 4.4 kilowatt hours, which I'm sure is bigger than most of the batteries that you can source at any of these battery builders. Not only that, like I said, I solder my batteries, which takes a whole lot more time to do. It is not a zip, zip, zip easy thing. I am doing it using the best means possible. I'm not going to sit up here and explain why I think my work is worth $1,000, but that's what it is. So whatever your cost of your cells is plus $1,000, that will make batteries around, you know, comparable to most of these battery companies. And for the most part, my custom batteries, you're going to get a much bigger battery as far as capacity and, you know, discharge amps. I guarantee you that my battery can discharge 600 DC line amps and 60 amp hour. Okay, all right. Now, as far as your battery, you can use whatever cells you want in your battery. You tell me what size battery you want, what kind of range you want. We'll calculate, you know, depending on which cell you choose, how many cells you're going to need, and everything. I'll take care of all of that. I'll need the dimensions of your bike or your battery compartment, whatever, and like I said, I'll design the battery. Let's see what else. Oh, okay. Now, my custom racing pack, I don't have a BMS on my battery, but that's my battery. Okay. Now, I definitely would want to put a BMS at least on the charge side on any battery that I sell to a customer. And matter of fact, there will definitely be BMSs at least on the charge side. Mandatory. I'm not selling any batteries without a BMS on the charge side. Now, I mean, if you don't, then again, if you don't want it, then you won't get it. But for the most part, each and every battery will have a BMS on the charge side and on the discharge side if that's what you wish to have. Okay? Me, myself, I wanted the maximum current possible, and that's why I don't have a BMS. Now, let me explain something that I've been hearing people say about BMSs and bypassing BMSs on batteries, stock batteries, and people are completely wrong. Well, not exactly, but for the most part, they're not 100% right. I've heard people say stuff like, if you bypass your stock battery, you're shortening the life of your cell. Yep, blah, 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 blah. That is not true. Let me tell you, the reason why you short your battery life on any battery is if you overcharge your cells, or you are drawing too much current from your cells to the point where they're getting hot. The hotter your cells get will affect how many cycles you get out of your battery. And the reason why your cells will get hot is if you're pulling too much current from them. Now, let me give you another example and let's just say this is a stock battery I'm talking about, hypothetically, and why, if we did a bypass, that doesn't mean it's going to shorten the battery life. Now, let's just say there was a stock battery that had an 80 amp BMS, okay? This battery had an 80 amp BMS, but it was a 72 volt 10P battery, and the cells in this battery were 15 amp cells. 15 amp cells, 10P. That means that battery was capable to produce 150 DC line amps. That is what that battery can safely produce, no problems at all, and those cells will not get hot because they're producing what they're designed to do, which is 10 amps per cell. Now, that 80 amp BMS is limiting that pack to 80 amps. So if you were to bypass that battery, you would get the full 150 amps. Now, depending on what controller you were using and how many phase amps you have that controller set to will determine how many amps you actually pull from that battery. So if you have a Saviton 72150 and you have it set to 350 phase amps, 150 DC amps, and you bypass that 80 amp BMS, you will not be shortening that battery's life, because that is what that battery is designed to do. Now, here's the difference. Let's say you bypass that same battery with the 80 amp BMS, 150 discharge amps, but instead of a Saviton 72150, you put a BAC 4000 on it, and you were attempting to use 300 amps from that 150 amp battery. You wanted to extract 300 amps. Now, you may be able to do it because those 10 amp cells may be able to produce more than 10 amps, but that is not the safe amount of current that it can produce and perform, efficiently. So if you pull double that or triple that, that's going to cause those cells to heat up, creating those extra amps. All right, that is what's going to shorten the battery life, not because you bypass the BMS, but because you are attempting to pull more current than that battery was designed to produce. So it's not the fact that you bypass the BMS to shorten the life, it's the fact that you're trying to draw too many amps. So when you say things, make sure you say them correctly. Alright, so if you bypass that BMS and you use the amount of amps that that battery can produce because of the cells it has, that battery will be fine. Alright, so I just want to make people say the right things. Alright, so that's pretty much it. I talked about what I wanted to talk about. I talked about the differences in why impedance matching is going to make a system more efficient, such as my system. I talked about why match a battery that has its impedance, its internal resistance low, because it was designed to be low, will last longer. This battery, because it has a low internal resistance, because I have impedance matched these power wires, will get a lot more charge cycles than a battery that was just welded together and wires just cut and slapped on there, no impedance matching was done, and that battery gets hot after you went on a group ride for an hour, 2 hours. At the end of your ride, you go to touch your battery and your battery's hot, and my impedance matched battery over here is cool as a cucumber. All right, so yeah, there's a difference when a technician or engineer builds something and back alley guy making batteries build something. Although I encourage DIY all the time, there's somebody told me this same guy, there's a right way and a wrong way to do things. He's right about that. You know, like I said, there's nothing wrong with these the way these batteries are being built. There's just next level building that can be done by somebody that really knows, you know, electronic theory, motor theory, and all that kind of stuff. There's a lot more I could say, but I think I've said enough. Alright, by the way, this is the battery I had to build for a subscriber. This is a 16S battery. Yes, a 16S battery. You figure out what that is. You know, anyway, I built this battery to the spec that the customer needed. Obviously, you see there's 2 power wires on this battery. There's a reason for that. This customer, this is a big old battery too. Although it's only 16S, as far as, you know, its amp hour, this battery is huge. It's a 16P. Anyway, this customer is using this battery to run 2 motors. He has a hub drive on his front wheel, and he has a mid drive on his rear wheel, and he has 2 controllers, which is why it has 2 power leads, and one controller obviously needs a lot more current than the other one, so that's why this power wire is 0 gauge, and this one is 4 gauge. All right, now notice they're different lengths. That's because they have been cut for, you know, to match the impedance internal resistance of this battery. When you measure its internal resistance from right there, it is very, very low. I'm not going to tell you what it is, because some people don't even know what it should be, what the internal resistance of a battery should be. But I'm not giving up all my secrets. That's why, like I said, this power wire is a different length, but because it's a 4 gauge, it's the length that it needs to be, that when you measure its internal resistance right here at this point, it's low as well. Now, I can't make his entire system efficient because I have nothing to do with his motors and all that and his phase wires, but as far as his battery is going to be very efficient. He's going to get the max out of this battery, maximum range, maximum power, all that. I'm pretty sure I forgot something, but oh well. All right, y'all. So you've heard it. I said I'm charging $1,000 for my custom batteries that I'm using copper that I'm soldering in. Now, if you don't understand or believe anything I said about the soldering and the copper and all that, and you want nickel strips in your battery and you want your battery welded, fine by me, because I can probably build that battery in 1/3 of the time that it would take me to do it my way. My way takes a lot more time. You know what I'm saying? Now, is that going to change the price? Nope. I'm charging $1,000 for my labor regardless if I weld it or solder it. That's your choice. Alright? But for that $1,000, you can get the best, most efficient means, and that's soldering. But it's totally up to you. Alright, that's pretty much it. Any other questions that you may have that I didn't answer, put them in the comment section. Take it easy. Take care, y'all. This is Crisscrossing Wires. Oh, yeah. Also, I have 5 or 6 people right now that are supposed to be serious about having their battery built. Now, this is the way I'm handling it as far as who's first come, first serve. Depending on when I get $100 deposit, this non-refundable, that $100 deposit will secure your place as far as who's next. All right, send me $100 deposit. I'm gonna put my Cash App in the description, and $100 deposit will hold your spot. Now, right now, I only have $300 deposits. So although I'm talking to 5 or 6 people, the first 3 people have secured their place in line. Actually, I have one other person that I haven't received their $100 deposit yet, but I was talking to them before all of this, so actually they're first. But after, that's if they send me their money, then after them, then I'll do it in the order like that. All right. Now, that $100 is just for securing your position, but I won't be able to start on your build until I receive the I'm going to say the $1,000. I'm going to need that $1,000 up front, because that's going to at least buy the materials. Well, you know what? No, I'm not going to say my $1,000. I'm going to need at least, no, I'm going to say the $1,000. I would say the materials money, but that's going to make it too different on every build, whatever. Yeah, I'll need that $1,000 deposit so I can buy the materials. Point blank, plain and simple. Now, you don't want to do that, then you won't be dealing with me, and that's fine. All right, so like I said, you got any more questions, put them in the comment section. I'm tired. Deuces. Hey, homie, whose battery this is, as you can see, it's a wrap. So hit me. Well, I'm gonna call you as soon as I upload this video and figure out how. I guess we're gonna meet up since you're not that far. All right, we out.